From my last video, we were able to apply dynamic VLAN assignment on a wireless connection. Wireless client device attempting to connect to this single SSID named Unifi will be required to enter user credential, and once authenticated, the client machine will be assigned to their respective VLAN. This system of authenticating a user and authorizing for access is called 802.1x. There are three components of 802.1x: supplicant, authenticator, and authentication server. A supplicant is the end user wireless client device that will attempt to connect to the network. This Unifi AP is the authenticator, which accepts the request and acting as proxy for the user client machine. The request will be sent over to the authentication server, that is server 2022 running NPS, and decides whether the user is valid or not and place it on a VLAN. That is just my short explanation about 802.1x. In this video, we'll extend 802.1x to the wired connection. This switch will be the authenticator, just like the Unifi AP, except the connection request will be coming from a wired client device. This wired PC, which is the supplicant, will need to enter user credential first, and the authenticator, the switch, will relay that request over to the authentication server running NPS and make the decision. Before we go further, let me just provide some background of why doing 802.1x on a wired connection. This is what it looks like without 802.1x back in my previous video when I set up this switch for the first time. The goal back then was to just assign a wired PC to a VLAN. There is no user authentication. VLAN assignment is hard-coded or statically configured into the switch port itself. In this case, port 3 is configured as access port, untagged on VLAN 10, while port 4 is configured the same but on VLAN 20. In this kind of setup, Windows 11-1 that is plugged into port 3 will be in VLAN 10 right away. The same goes for Windows 11-2, it will only be on VLAN 20 once plugged into switch port 4. In other words, VLAN assignment follows what is configured at the switch port. Let us jump into the switch and see how the ports are configured. Under VLAN management, let us click Interfaces. GA3 or port 3 equivalent is manually configured as access mode with port VLAN ID or PVID of 10 and untagged on VLAN 10. While GE4 or port 4 equivalent is configured the same except it is on VLAN 20. GE1 or port 1 equivalent is in trunk mode or the default mode and tagged on VLAN 10 and 20. This is the connection going to the LAN of the firewall. This GE2 or port 2 equivalent is the connection going to the Unifi AP, but I'm going to take Unifi out of the network topology since we are not going to use it for this video. In the topology, here is port 1 or GE1, which is in trunk/tagged that connects to the LAN port of the FortiGate firewall. Here is port 3 configured on VLAN 10 and port 4 configured on VLAN 20. We are going to remove the hard-coded VLAN assignment configuration to both port 3 and port 4. Back in the switch, we'll change GE3 and GE4 to their default settings, that is trunk and untagged on default VLAN 1. Edit GE3 and select trunk. I'll do the same for GE4. Both GE3 and GE4 are in trunk mode and on default port VLAN ID 1. These ports now do not belong to any specific VLAN except the default VLAN 1. Next, we'll configure radius on the switch. Go to Security, select Radius. Click Add, enter 10.10.10.220, which is the server 2022 IP address running NPS. Leave the authentication and accounting ports as it is. I'll just put one in here for the priority. For key string, select user defined and enter a password in here. This is actually the shared secret key that needs to be matched when configuring server 2022 NPS later. Select 802.1x for the usage. I don't need accounting for now. Under Network Access Control, select Feature Configuration. Enable Port-Based Authentication. Select Radius for Authentication Method. We have an option to enable Guest VLAN. What this does is when a user failed to authenticate or the supplicant does not support 802.1x, the client machine will be assigned to this Guest VLAN subnet. Maybe just for internet connectivity without any access to internal resource. I don't need guest VLAN for now, and we leave this off. Next step is to enable 802.1x on GE3 and GE4 ports. Under Port Authentication, edit GE3, select Auto for Port Control. Leave host authentication mode in multiple host 802.1x. Enable radius VLAN assignment. Ensure 802.1x authentication is checked or enabled. Then click apply. Do the same process for GE4. We are done configuring this switch. While we are at the switch web management, let us test connectivity if we can reach server 2022 IP on 10.10.10.220. Before we do that test, let me show first the management IP address assigned to the switch. Under IPv4 interface, static IP address assigned to the switch is 192.168.1.205. which is the LAN subnet of the firewall, and gateway IP is 192.168.1.1, that is the LAN IP of the firewall itself. Any system-generated traffic at the switch will be forwarded to the firewall LAN IP at 192.168.1.1. When either ICMP or radius traffic generated at the switch is going to server 2022 IP, FortiGate firewall will either allow or deny the traffic depending on the firewall rule in place. Back at the switch management, let us do the ping test going to server 2022. Go to Maintenance, under Diagnostics, select Ping. Enter 10.10.10.220 for the target IP address and click Start. Ping results shows a ping failed timeout and 100% packet loss. What do you think the issue here as to why this server 2022 is not reachable? Is it because there is no firewall rule allowing the traffic? Let us jump into FortiGate firewall and verify. Let me show first the configured interfaces in here. Port 3 is for the DMZ with an assigned IP address of 10.10.10.1 with /24 subnet mask. Port 2 is for the LAN with an assigned IP of 192.168.1.1 with /24 subnet mask. VLAN 10 and VLAN 20 are sub-interfaces of LAN port 2 with their assigned IP of 192.168.10.1/24 and 192.168.20.1/24 respectively. Port 1 is for the WAN with an IP 192.168.8.120 with /24 subnet mask. This is just a simulated WAN, and this network address 192.168.8.0/24 is behind the LAN of the router. Let us examine the configured firewall rules by going to Policy and Objects. Select Firewall Policy. There is a firewall rule for LAN to WAN traffic. Anything from LAN subnet, VLAN 10 and VLAN 20 subnets are allowed to go out to the WAN or Internet. This second rule here is for WAN to LAN traffic, for accessing the switch web management over the WAN since the switch IP is behind the LAN. This is what we call port forwarding rule. I'll probably create a separate video about port forwarding. When none of the traffic matches the configured rule above, this implicit deny rule will be matched, and that is to deny everything. And that is the reason why we can't reach or ping server 2022 IP from the switch. Let us create a firewall rules to allow traffic coming from switch IP on LAN going to server 2022 IP on DMZ. I'll name this rule as switch to server. The incoming interface is LAN port 2. Outgoing interface is DMZ port 3. From the topology, the flow of traffic from switch IP 192.168.1.205 will ingress on LAN port and egress on DMZ port to reach server 2022 10.10.10.220. I'll create an object for switch IP 192.168.1.205 and select it as the source. I'll do the same for server 2022 and select it as destination. Schedule is set to always, which means active all the time. For service, I'll select all for now, but this can be granular, allowing specific ports or protocols. Action is accept. Uncheck NAT. We don't need NAT for this LAN to DMZ traffic. I leave everything below as default and click OK. We have this rule in place now, allowing the switch to get to server 2022. Back at the switch, let us do a ping test once more. Ping result shows it is a success and we have 0 packet loss. Next, we go to server 2022 and configure NPS. Everything that is configured in here was from that video about dynamic wireless VLAN assignment. Please refer to the link in the description. We have one radius client in here that is Unifi AP. Under connection request policies, we have this for Unifi as well. Under network policies, we have 2 policies in here. So VLAN 10NP will be matched for a user that is a member of Kaiju group and will be assigned to VLAN 10, while VLAN 20NP is for a user that is a member of Diode group and will be assigned to VLAN 20. Now I'll be reusing this exact same policies. See part 2 of the video about dynamic wireless VLAN assignment for the details. In Active Directory users and computers, just to review here, Kaiju group members are these 2 and we'll use King Kong user for the testing. And here are the members of the diode group and we'll use photodiode user. Back in NPS, let us create a radius client for the switch IP. Right-click Radius Clients and select New. I'll just put switch for the friendly name. Enter 192.168.1.205, that is the switch IP address. The shared secret here must match exactly the one we configured at the switch earlier. Next is to create a new connection request policy. I'll name this as switch CRP. For the condition, select client IPv4 address and enter the switch IP address 192.168.1.205. Click on next until finish. For the network policies, as I mentioned earlier that I'll be using the same 2 policies, VLAN 10NP and VLAN 20NP, since we are matching the same users in a group. We are done configuring NPS or the authentication server. Next, we go to Windows 11-1 VM or the supplicant. I'm opening network connections here just to show the status is unidentified network and has an APIPA IP address 169, as I have not connected this yet to the switch. First thing to enable here is 802.1x on the Ethernet interface. Go to Services and select Wired Auto Config. Service status is stopped by default. I'll change the start type to automatic. Click start and apply. Wired auto config service is now running. Back into network connections, double-click Ethernet 2 and click Properties. Go to the Authentication tab. Check the box to enable 802.1x authentication. Leave Microsoft Protected EAP or PEAP for the authentication method. Under Settings, leave everything as default. For the advanced settings, enable Specify Authentication Mode and select as User or Computer Authentication. At this point, I have connected this VM already to the switch at port 3. Ethernet 2 status is now attempting to authenticate. Looks like it is not authenticating, and we don't see any prompt to enter a user credential, right? In the topology, this is Windows 11-1 VM connected to port 3 at the switch. The expected behavior is that before we get access to the network, we should get a prompt to enter a username and password. Then the switch will relay that user credential over to NPS. Back to Windows 11-1 VM, I'll disable and re-enable this Ethernet interface. In the network and internet settings, we have a button to sign in. Let us click sign in. It is still not giving us the option to enter a username and password. I have stopped the recording and performed some troubleshooting, including restarting the VM, do some Windows update, tried the second Windows 11-2 VM, tried different network adapter settings in proxmox. Nothing seems to work. I was thinking maybe the Ethernet adapter is not compatible, or this will not just work on a virtual machine. So the last thing I did here was to test a physical computer with a built-in Ethernet port. It is unplugged at the moment. Started the wired auto config service and enable 802.1x on this Ethernet interface. I plug this into port 3 at the switch. Let us watch how this behaves. Now we have a notification below that action is needed and a button to sign in. Click sign in. It redirects to the network and internet Ethernet settings, and we have seen this earlier in Windows 11-1 VM. And now this time we got a prompt. I'll enter in here user King Kong and the password. Looks good so far. Before we continue to connect, let us click this Show Certificate Details. This confirms that we are connecting to the correct server. It is still showing the status as an identified network. Let us refresh the network connection screen. Looks like we have a connection then. Checking the connection details, it has now a DHCP assigned IP of 192.168.10.101, which is on VLAN 10 subnet range. The physical or MAC address is ending in 82-4C, and we'll verify this at the switch. Let's jump into the switch web management. Under Network Access Control, select Port Authentication. Port 3 is now authorized. Under Authenticated Host, this table shows the username King Kong. MAC address here is ending in 82-4C, which matches the computer. Connected on port GE3, assigned VLAN is 10. We have session time, and the authentication method is 802.1x. Let us now try to log in a different user. I have unplugged the cable and plugged it back in so that it will attempt to authenticate again. Click sign in, and this time it directly went to the sign in prompt. Log in as photodiode. Refresh the network connections. This time, the computer has acquired an IP of 192.168.20.101, which is on the VLAN 20 subnet range. At the switch, refresh the authenticated hosts. This table now is updated with the username photodiode with the same MAC address ending in 824C on port GE3 assigned to VLAN ID 20. Let us also verify the NPS logs at server 2022. Open Event Viewer. Expand Custom Views. Expand Server Roles. Select Network Policy and Access Services. We can see the latest log entry in here that is for user photodiode. We can see the Radius client switch IP 192.168.1.205. Under Authentication Details, the connection request policy name is switch CRP and the network policy name is VLAN 20 NP. If we click on the second log entry, this is for the user King Kong. Same Radius client IP 192.168.1.205. Same connection request policy name switch CRP, but the network policy name is VLAN 10 NP. If you want to add granular control over what network address or IP can VLAN 10 or VLAN 20 users can access, you can just add a firewall rule in here. That is all for this video about port-based authentication or wired dynamic VLAN assignment. Let me know your thoughts about why the Windows VM is not able to authenticate. Take care and see you on the next video.